Hello everyone, so talking about diffusion today and in particular with lungs. So diffusion is something you might talk about briefly when you were doing cells in either your previous class with your previous teacher, or if you've always been in my class you would have done it with me. So just as a reminder, diffusion is the movement of particles from a high concentration to a low concentration. Now when we say high concentration we mean where there's lots of them, and when we say low concentration we mean where there's not many of them. So my example here, this is the high concentration and this is the low concentration. That's where there's lots of particles, that's where there's not many. They will spread out in this direction until they are all evenly distributed or placed. Okay, so diffusion, the movement of particles from a high concentration to a low concentration. Now we say that the rate of diffusion means how fast it happens. And there's lots of things that can affect the rate of diffusion. So temperature is one. If it is hotter, the rate of diffusion will be higher or diffusion will happen faster. If there is a really big difference between the high concentration and the low concentration, so for example, if there's 100 particles on one side and 1 on the other, there's a big difference, then it will happen faster. If the particles don't have very far to travel, it will also happen faster. That will help you with the answer to the first 3 questions on OneNote. Now I'm going to stop and I'm going to talk to you about question 4, which is about relating this to the alveoli and the lungs. So when you breathe in, your air goes through your nose, down your trachea, through your bronchus, into your lungs, and they end up in these little sacs called alveoli. Now if we zoomed in on one alveoli, it would look a little bit like this. Okay, so we have hundreds and thousands of these in our lungs. So the air comes in through here, that's the air that we breathe in, and around it we've got blood vessels or capillaries. Now those capillaries are carrying blood that has got carbon dioxide in because it's come from our body. Now the idea is, as you can see, that carbon dioxide comes out of our blood into our alveoli, ready to be breathed out. Air that's coming in has got oxygen in, and that oxygen moves into our capillaries so it can go around our body for us to use. So if I just go through that again, this is a red blood cell with carbon dioxide in. It gives the carbon dioxide to the alveoli, that travels out of our alveoli, ready to be breathed out. At the same time, the air we breathe in comes into our alveoli. The oxygen from that air is given into our capillaries, into our blood cells, and then carried around the body. Now, the reason this is an example of diffusion is these arrows, all the arrows are representing the diffusion, the movement of those particles. So we look again here, when the blood comes in, the blood has a high concentration of carbon dioxide compared to the alveoli. So the carbon dioxide diffuses from the blood into the alveoli and then diffuses out, and then that's when it's going to be breathed out. On the flip side, the air comes in, that's where there's a high concentration of oxygen and a low concentration of oxygen is in the capillaries. Therefore, the oxygen diffuses into the capillaries from the high concentration to the low concentration, and then it's taken around the body. You can now answer question 4.